Okay, so today I'm gonna talk to you about how to build products using data. And for those who don't know me, my name is Rafael. I'm VP of Engineering at Stable, and you can find me on Rafael Ugolini in Twitter. So I think the first thing that I wanted to talk is the agenda. Like I will start with an introduction with like some concepts of data and things that we have been observing, the tools that we use internally in some analysis that we did, and how we took decisions and what was the mindset that we had when we were doing product decisions and design decisions using data, the key insights that we had and a conclusion, right? So I think like the first thing that I wanted to bring to you is like data everywhere. And in our lives, we use it very frequently. So if you think about experience, is things that you have experienced before. Let's just say like that when you went to I don't know, a party or something like that, it's something that you know that it happened because you already have that experience. And emotions is things that like you had feelings about. So when you experience something, like what would the feeling that gave it to you? And then you have like knowledge, which is things that you didn't experience, but you know what is it about. And with those three sources of information, you take decisions every day in your life. So with that in mind, you can think about like how people were building products in Web 2. So while using data, you can think about like people building products. They were generating a lot of metrics, and most of this data was by user analytics and some sort of CRM. So you can see that customer acquisition cost and average revenue per user and all of these kind of metrics are generated over some sort of like Google Analytics and a CRM data linking together. But you have a lot of challenges with that in Web 2. So most of the time you cannot use the data. You need a lot of like terms to actually be able to tackle the data from customers and things like that. And it's very challenging to do that. But even though Web 2 actually used it in a very efficient way. So I feel like one of the best examples that you can have is UX. Because Web 2 built a world-class UX. And I think Marisa Mayer from Google, she was a clear example of how using data was a killer thing for them, right? Like because she actually made UX at Google way better just by using data, and she was not a creative designer for that, right? So how do we apply that to Web 3? And I feel like one of the key points that you can think about this is how Web 2 was doing that. Like, so you had a product manager who knew how to ask good questions, who were in touch with the customers, and who really understood the product. You have a data scientist who actually know how to use the data to grab the data and understand it, the meaning of it, and etc. And then you have software engineers who build the whole system for it, right? So with this team, they were able to transform data into insights. And I feel like this is something that I want you to really think about this, because a lot of like Web3 teams are very small, but this is how people are doing in Web 2. And with that in mind, like I want to bring you a little bit of the tools that are available in Web 3 for you to start like looking into data, right? And I feel like this is the ones that we have been using in some analysis that we did, because what I will show you here today is a real use case of data that we use it at Mstable to build products, right? So if you think about like what we have been using on this exercise, we're using Fura. I don't know if any of you guys know, but probably yes. So we're using Fura mostly for the archive node. And something that is really nice because it removes a lot of the barriers to spin up one. And their free plan is pretty good, and it offers like 100,000 requests messages. We use also Etherscan as a block scanner, so it's actually pretty good when you want to interact with the contract and just do some tests and see the events and things like that. So I think it's a pretty useful tool. We use pandas as well, and together with Check the Chain. Check the Chain is I think is like one of the most unknown tools here, but it's a tool that was built by the Fay team. I think like specifically Storm was the one developing this, and this was really helpful for us because we could grab a lot of the data and transform it directly into pandas, and it was really easy for us to manipulate that. But there is also a lot of other tools that you should be able to look into it, which is the graph, Dune, token flow, and others, right? So when we were thinking about like using those tools, we started thinking, okay, like now we have all of this access to us, what can we do, right? So how do we start taking product decisions on that? And I feel like this is where like that team that I presented to you before come very handy here. So one of the main questions that we had while we were building products was like, how do we split the users of the contract and how do we classify them, right? So do we know which users are this? Because Web3 is very hard because you don't have like, there's no like login, right? And then you can start looking into it. So you just have addresses. And then how do you know what is their addresses? So one of the things that we looked into it was like, which is the address type? Are these contracts? Are these multi-sigs? Or are these just users, right? Like external owned accounts. And after that, we started segregating them by what is the amount of like liquidity that these people are putting. So we used the sea creatures that everybody was kind of using before, but we needed to adapt a little bit their sizes. So like a shrimp would be something that is less than 20,000. A crab would be someone between 20 to 100,000. And then like the biggest one would be a whale that is above 10 million. So that's how we started like defining the personas of the product that we're building. And then here is like a small example of a code that would actually help you to identify that. So I think the first function is to really understand, okay, is this address a contract? And the second was kind of like, okay, you know, like if I call a name and it returns, if it returns me like the Gnosis save, and there was another name that I forgot, which old Gnosis contract, we will declare that as a multi-sig. And here is how we started like looking into how to check the size of our user. So we started looking into the whole time this user has been in a pool, providing liquidity, and we got the maximum amount of balance that they were there, right? So another product decision that we had, it was like, how long did a user stay in the pool and how many times did they claim? So I think I forgot to mention here, like before, what is this like, where are they depositing and which pools and claiming part? So in this example, we are using curve and convex. So that's what we were analyzing it. So in this like user behavior that we wanted to understand is like, okay, when does a user get in the pool and when do they get out and how many times do they claim? So I think like one of the things that is interesting to notice here is that we do in this exercise, even if the user claimed once and they have two positions, we calculated that it claimed one in each position because we wanted to look into the average of the amount of times that the user was claiming. This was getting a more real data for that. And here is like a small testing that we added to our algorithm to calculate that. So we use Python with pandas to do that. And then you could see like we just perform some scenarios for Alice. Let's say Alice deposit 10,000. And then we can just see like all the steps that we were taking to do the back testing. Okay, another point that it was very interesting, it was design decisions. When we had all this information about the product, we wanted to understand when to liquidate, which kind of data do we use to do that? Like what do we look? We look at the gas price. We look at the amount of rewards that they were having and all of these kind of things. And then we were looking also the fee models, right? Like how much fees can you charge for a user until it's benefit for both parties? So we wanted to use like a positive sum way for this exercise to make sure that we were making money and the user were making money. And we wanted to achieve like an 80% factor on this. And there was some other design decisions that we were thinking about. And this was like another big topic that our data scientists built, which is like the stablecoin framework and which kind of like stablecoins we would use for some of these pools and why is that. So I feel like this is like one of very interesting points is like when we started looking at the key insights, right? I think before we jump into this, I would like mention the pools that we use to do that. We went into Curve and Convex and we started analyzing based on the stablecoin framework that we had. We look into the BUSD, MUSD, and Frax. And at the time that we were looking at Frax, it was Frax Curve. It was not the new pool of Frax. But I think like one of the very interesting points that you see here is that dolphin, sharks, and whale, they represent almost the whole TVL of the pools. And what is very interesting is that in the next chart, you see that the address distribution. So you can see that dolphin, shark, and whale are a very small amount of addresses. And it started like you're thinking, right? Like, okay, like how many users am I targeting in this product? Like, is it worth targeting shrimps and crabs? Like, what are the users depositing there? Is like Convex and Curve an expensive game and only like whales are joining there, providing the whole TVL. So this was like one thing that we're thinking about. Another point that was super interesting for us, right? How long do the users stay in the pool? So we noticed that majority of the users, they would stay in the pool between 1 to 60 days. So thinking about that, we were just thinking, okay, like how do we calculate this time? How much TVL would they get? And how many times they would claim, right? So this was like a super interesting point, which was with all of that data, what we did we did a simulation of a 6% yield. So let's just say, okay, like with that in mind, let's calculate that all of the users will have deposited and that pool would generate 6% of APY. How much money they would get if they were having these scenarios, right? They would stay, I don't know, 1 day to 30 days, 31 to 60 days. I think here it's like you can see it. The majority, I think almost none of the users will actually get the 6% yield. So we even remove I even removed here the shrimps and crab because shrimps were actually losing money. And crabs was like also sometimes they were losing money. Like they were literally not getting the APY that it was offered to them. But you can see that even octopus, they get very low APY. So one of the things that also was interesting, it was like the variables that we noticed that it would affect your APY in this exercise, right? So it was the TVL, it was time, and number of times that you would claim in a pool. And that was the main points of influence on the whole calculation. And I wanted to add a small conclusion here, which is you saw this data, but what I wanted to say is that data can be noise, right? If you don't have a team that knows how to ask the questions, that knows how to build the integrations, that knows how other protocols work and how like you would get that event and things like that, you were not going to be able to find it, right? There would just be noise or shards, and it would be very difficult to get insights from this. So I think like what I want to really sum up is that the conclusion of this is that you need a team for that. Otherwise, we're going to need to be counting that you have a unicorn, that is that profile that will know product management, that will know how data works, that will know like engineering part. And it's way easier to learn from how Web 2 has been doing in the past and actually having a team for that. And I think that's more or less about it.
Amazing.